See, now we are going to discuss about diffraction by a lens, and what we are going to derive is known as lens maker's formula. Already in 10th class, I think you might have derived this equation, but we are going to do it in a rigorous way. We are going to derive it using geometrical laws. Let us consider a thin lens. This is applicable for thin lens. So let us consider a thin lens, and let this be the axis of the lens. Let us suppose this is one pole, this is another pole, and let O be the object. A ray coming from this like this, and another is going like this. So here, say it is incident at a point, say N1, and gets refracted, and finally the image is formed at I. So let us suppose this is the point here. Now we will solve this problem by dividing this into two curved surfaces. One is this side, the other is that side, and then we will apply the formula we derived in the earlier case. So that is, I have shown you that for a curved surface, this is N2 by Mi plus N1 by Mo is equal to N2 minus N1 by Mc. Here, M is nothing but the center of the curved surface. Already I told you in the previous case. But here, we consider one curved surface with B as the center, and the other curved surface with B as the center. And then we find out the final formula. So for the first curved surface, as you done, as it was done, so I will directly use that formula. So that is N2 by Bi1. In the place of N, I am writing B plus N1 by Bo, that is equal to N2 minus N1 by Bc1. So C1 is the radius of curvature of the first curved surface. N1 is the refractive index of the rarer medium. N2 is the refractive index of the denser medium. Now let us come to the second curved surface. For the second curved surface, the image formed by the first surface I1 acts as object. So I have drawn the figure for the formation of image by the second surface. And here this is the incident ray, this is another ray, and after refraction they meet at I. Now here from the R2, from the figure, this R2 is the angle of incidence in the denser medium at the second surface, and I2 is the angle of refraction when the ray comes out finally. So this is the normal here, which passes through the center of curvature C2. So from the geometry, angle R2 is equal to, so this angle minus this angle, that is N2 C2D, angle N2 C2D minus angle N2 I1D. So that is what I have done here. So in the place of the angles, tangents are taken. So tangent of this angle is dN2 by dC2, and the tangent of this angle is dN2 by dI1. So that is what we have done. Similarly, for this angle, which is the exterior angle for this triangle, so sum of this angle, so angle N2ID plus angle N2C2D, so that gives I2. So in the case of angles, I have taken the tangents, that is dN2 by dI1 plus dN2 by dC2. Now let us make use of Snell's law. So what is Snell's law? That is N2 sine of R2 for this medium must be equal to N1 sine of I2 for the rarer medium. Since the angles R2 I2 are very small, according to approximation, we can rewrite like this: N2 R2 is equal to N1 I2. Now let us substitute that, and here you see on either side dN2 is common, that gets cancelled. So directly I will write like this: N2 by dC2 minus N2 by dI1 is equal to N1 by dI plus N1 by dC2. So I cancelled dn to either side and distributed n to this side and n1 that side. Now bring this dc2 to this side. Then what will happen? n2 minus n1 by dc2 is equal to take this n2 di1 minus and then it goes to plus. So that is n2 by di1 plus n1 by di. So that is the equation. Now we know that B and B, as I said earlier, are very nearer. So therefore I can substitute, replace that D by letter B because these are thin lines. Hence, from this equation I can write like this: n2 by bi1 plus n1 by bi is equal to n2 minus n1 by bc2. Why I have written like this? So D and B are very nearer for thin lenses. I replaced it. Now let us apply the sign convention both for equation 1 and for equation 2. So bi1. So here it will be positive. BO, object distance, negative. BC1. So this will be positive. In the equation 2, bi1 here. B means D, so this distance, that is we are measuring in opposite direction, will be negative. Bi, so that means Bi, so this will be positive in the same direction we are measuring. And BC2, that means radius of curvature for the second surface, opposite direction, hence you will put in minus. Now let us add both 1 and 2. Adding equations 1 and 2. So what we get is this n2 by bi1 gets cancelled. Then n1 by bi minus n1 by bo is equal to n2 minus n1 common, and that is 1 by bc1 minus bc2. Here let us use the usual symbols. Bi is nothing but the final image distance. Final image distance from the center of the lens. So that is n1 by b, and this is object distance u, and this is n2 minus n1, and this is radius of curvature of this curved surface, first surface, and this BC2 is the radius of curvature of the second surface. So therefore this is 1 by r1 minus 1 by r2. And take this n1 to that side. So what we get is 1 by v minus 1 by u is equal to n2 by n1 means that is n21 minus 1 into 1 by r1 minus 1 by r2. And from this equation, this is the equation. So from this equation we can find out the relation between image distance, object distance, and the radii of curvature and the refractive index of the two media. Now suppose if this object is at infinity, what happens? See, suppose if the object is at infinity. So if the object is at infinity, u will be infinity, 1 by infinity will be 0. Then the image distance is equal to focal length of the lens. We assume that the rays coming from a faraway object are parallel when they are incident on a converging lens. So they converge at the focus. Therefore, we can take V as equal to 1 by F. Therefore, from the equation, we can say that 1 by F is equal to N21 minus 1 into 1 by R1 minus 1 by R2. So, this is called as lens maker's formula. So why this called lens makers formula means if you know the focal length of the lens and refractive index of the glass you are using, then by giving proper curvature to the surfaces, an optician can prepare suitable lens. So he makes uses of this formula to design the proper radii of curvature to the curved surfaces to produce desired focal length. So that's why this is called as lens maker's formula. Also from the same equation, since 1 by f is equal to this one, but your n21 minus 1 by r1 minus 1 by r2 is equal to 1 by image distance minus 1 by object distance. So we can write like this: 1 by f is equal to 1 by v minus 1 by u. So this is called as lens formula. So in this way we can derive lens maker's formula and the lens formula by applying the concept of diffraction curved surfaces. And one more point is regarding magnification. So regarding magnification, as we discussed in the case of mirrors, the size of the image by the actual size of the object, that is called linear magnification. Similarly, in the case of lenses also, we can define magnification like this, that is image size by object size. So we will get V by U. Same formula we will be getting, and if the image is inverted, we put negative sign.